we go. Subtraction, just like addition. All right, so here are my line segments. I don't need you to copy them down. They're the same ones from yesterday. I got A and B, they're congruent. And I got C and D, they're congruent. But now I don't want to put them together. I want to take C and take that away from A. So A minus C will be the same length as if I did what? B minus D. Or I could have done what instead? I could have done A minus D, and that would still be the same length as B minus C, but we're not going to call it addition, obviously. We're going to call this now subtraction. Questions there? All right, here we go. Let's apply it to a proof now. You can thank me later. Everything's written in for you. You can thank me later. Angle DAC. Ooh, what type of angle is DAC? Straight angle. And it's congruent to ECA, which is also a straight angle. I don't know how you want to mark. I can mark it like that, I guess. With my little arc marks. And I gave you another pair of congruent. One congruent to 2. So I can do double arc marks on those. 1 congruent to 2. And I need your help getting 3 and 4 congruent. All right. Yesterday was no big deal. It was always addition, addition, addition. Now you got a decision to make. Addition or subtraction. Okay, you got a decision to make. And yes, I know everyone's just going to say it's subtraction because you know it's subtraction day. All right. But why subtraction? Why not addition? All right. Everyone see the straight angle that was given. And I need to get to angle 3 in my proof statement. So here's the question I need to answer. As I go from the straight angle to angle 3, is that angle getting bigger or smaller? I'm getting smaller, smaller, smaller. Everyone agree? So the only way I'm going to get smaller is if I subtract. How many pairs of equal quantities you need to subtract? How many did I give you? We're ready to subtract then. I just need to know what you're subtracting. Going to give me the angles I need to subtract. Oh boy, suspense, suspense, everybody. Here we go. 2. All that for you, Natalie. Okay, so I'm going to take straight angle DAC, and what am I going to subtract from it? Angle 1, yep. And I know that's the same as subtracting what other angles? Straight angle ECA and subtracting that from angle 2, yep. Subtraction. But as we stated yesterday, whatever's in the proof statement needs to be your last statement in your proof. Whatever that proof statement is. Okay, what's another name for straight angle DAC and I take away angle 1 from it? What's left over? Angle 3. And same thing here. If I take straight angle ECA and take away angle 2, what's left? Angle 4. And that would be? Okay, it's not addition and subtraction. Work the same way. You just got to figure out substitution. Just got to figure out which one I'm using. Hey, you all good there? Yeah, 1 doesn't make you great, though. Our boy hasn't shown up in ages, huh? I told you. I told you. Doesn't happen often, so you better be paying attention when it does. Next up. Be careful here. I wrote this a little differently. I don't want to mess with your brain and get you rattled already. I put the given in there. That's the proof statement up above, all right? That's not your given. Okay, your given is in the proof statement already. I mean, in your statement's reasons already. So DF, I guess we can mark it this way, and BE are congruent. And I need to prove DE and BF are equal, though. From the given to the proof, is your line segment getting smaller or bigger? Okay, there's your answer then. It's got to be what type of proof then? Subtraction, subtraction. All right. What am I going to ask you next then? If you just told me it's subtraction, what is the next question out of my mouth always? Yes, Michael. Is there two quantities? Did I give you two quantities? Nope. So you're on the hook for the other one. So I need to figure out, what do I need to subtract? What do I need to subtract from DF and BE? EF, and hopefully it's the same thing. So I'll subtract EF, and then I'll write that as EF congruent to EF by what postulate or property? The reflexive. Now how many quantities do we have? Two, perfect. Need somebody to subtract those for me though. Oh, let's hear from 28. Is there one in the house? No, of course not. 20. Oh, it is. Thank you. Go right ahead. Perfect. Thank you. What gives you the right to say that? Good. And I'm glad you kind of forgot, because I was going to make a point. It happens every year. Kids go to write subtraction and they say it in their head, but you know what gets written down? Substitution. All right, so just be careful. All right, be careful. Have a little self-respect, right? Don't be an embarrassment to the math community. All right, so any different from addition? No, not at all. All right, I'm going to stop right now. Make sure I remember that it's there. Quiz tomorrow. You're looking at it. Right there. Okay? What I'm about to go over, not on there. So everything from reflection to subtraction. It will be 11 points. It will be short. It will be about 10 minutes. Here's what will be on there. If you remember beginning of your homework, remember these problems right here. Yeah, yep. Let's try that again. Oh, whoa, hey, easy, boss. Oh, boy. Now I'm rattled. Let's try just the old-fashioned way and scroll up. And that's still not going to do it. There we go. 1 through 4, you had on homework? Those will be like the first 3 or 4 questions tomorrow. What am I using? Okay, givens, conclusion, what am I using? You'll write it down, and then there'll be 2 proofs. 2 proofs, okay? Reflexive, substitution, addition, subtraction. That's all that's on there tomorrow. All good? Any questions about that? 11 points. All right, should go pretty quick if you know your stuff and are comfortable with it. All right, next one. And the final one for today, and this gives students the most fits, this final one, which says halves of equal quantities are equal. It's a mouthful, isn't it? It's a mouthful. Quick diagram to show you what's going on here. I have 2 line segments. They're what? Congruent. All right. I got 2 line segments that are congruent. I'm going to cut them in half. What do you know about the halves now? They are. Really? Why is that? Halves of equal quantities are equal. Why not, right? Just read it off. Yeah. If the originals were congruent and all I'm doing is taking half, shouldn't the halves be equal as well? Okay. But now I'm going to challenge you. Two vocabulary terms we talked about in Unit 1, which signal to you something's being cut in half. 3 and 4. Next period? Okay. 2 words.
Bisector and midpoint.
Whoa, gave me both. All right, caught me off guard. Bisector and midpoint. So if I start seeing those words in my givens, ooh, I'm cutting something in half. All right, everybody good? All right, let's get to our first one here with halves of equal quantities. Thank you. See? You don't need a diagram for this one. All right, you don't need one. I'm telling you that these two line segments are equal. Then in the next two givens, what am I doing to AB and DC? I am cutting them in half. I am giving you that I'm cutting them in half, and what am I calling them? AF and EC. What did I know about? I'm doing it again. What did I know about these two here? They were equal. And if you cut them in half, what do I know about their halves? Which I called AF and EC. And that is my new fact, which is halves of equal quantities are equal. So it's taking two congruent, and it could be angles too, taking two congruent angles or segments, cutting them in half, and saying the halves are equal. That's where I'm going to use this now. Anything about that? Because I'm going to throw a little wrinkle into it right now for our last proof of the day. Here we go. I got to prove that angle R is congruent to angle S. Look at the givens. We got a lot of givens going on, huh? What's happening to DCB and DAB? It's getting bisected. That tells me they're getting cut in half. What do you know about DCB and DAB? They are congruent. So let's go to our diagram right now. Everyone look for where DCB is. DCB. Let's mark it with an arc mark. Look at DAB. Don't start. Mark it with an arc mark. And what are you doing to those two angles? How do you know you're cutting them in half? Because you see bisection, you know what that means from unit 1. Great. So I should just write, R's got to be congruent to S, halves of equal quantities. No, this is not a two-step proof. Because, ready? Here's what you just told me using your mouth only. What angles are getting cut in half? DCB and DAB. You're telling me that, but did I ever write that in my statement's reasons? No, you don't get credit for telling me. You get credit for writing it down. That's where you make your money, up there. All right, not with your mouth. So I need to write down that I'm taking half of them. Yes? Just like, hey, didn't I write that down in the last proof that I was taking half? So if you want to use this, you better write down somewhere that you're taking half of something. All right, so let's go back and write that in step 2. Give me one angle that's being cut in half. So I'm going to go half of angle DCB. And I need to, just like I did in the last proof, I need to name that new angle. In this case, it was a segment, but now I got to name that new angle. So let's go up to my diagram right now. Everyone sees where DCB is. If you take half, you have two angles that end up. You have angle DCA, everyone agree this one right here? And you have angle S. So I could put either one right now in there. But I only care about one of the two. Which one do I care about? S, why? Because it's in the proof statement. So I'm going to say half of DCB is equal to angle S. Wasn't there another angle you're taking half of? Oh, angle DAB. And again, look, you got two options. You can say it's equal to DAC, or you could say it's equal to angle R. You'll be right, but I only care about one of them. Angle R. Okay, now many of you might write halves of equal quantities are equal. No, that's not how I know those angles are being cut in half. Yeah, there was that word up there, bisects. That's how I knew those angles were getting cut in half. So just like I did on day one, definition of a bisector. Do you know two angles are equal? Yes. Did you tell me they were being cut in half? Yes. So now you can tell me their halves are equal now. See how this process goes. You need a pair of equal angles. You need to tell me they're being cut in half and y. And then finally, you can tell me the halves, which I called angle S and angle R, are now congruent. And that will be what reason? Halves of equal quantities are equal. Last thing before I let you go on your own. If you're ever going to use this, you need what above it? Before you write this down, there are two things that you need. Congruent angles or segments, and what else? You need to tell me you're taking half of them. Okay? Sometimes, hey, sometimes it's nice because sometimes it may be given to you. Like I believe the first one in your homework is given to you already. Sometimes, like we just did, you're going to have to write them in yourself. Okay? Got plenty of time to get started. Go ahead.